Hey gang, so if you can remember back to the SN2 and E2 videos, I said that they are competing reactions, right? SN2 obviously happens when your substrate is less sterically encumbered, your methyl or primary, but E2, you're really gunning for that secondary or that tertiary substrate, right? Well, kind of in the same boat, SN1 and E1 slightly compete. However, it's not exactly the same. So the thing is, and let me just give you an example. When I give you this reaction, right, T-butyl bromide and water, we have a tertiary substrate with a good leaving group, so sterically encumbered, good leaving group, and we have a polar protic solvent. Well, if you've done some SN1 practice, you know that the bromine leaves, forms a tertiary carbocation like this. Water attacks, then we have a little bit of a cleanup step, and we would expect this product, T-butyl alcohol. Well, there's a little bit of a side reaction, and it's actually elimination. So let me draw the mechanism down here to show you what other reaction you can expect besides the SN1 product. So let's do the whole thing. And I'll use different colors. I'll use black for my arrows to kind of differentiate from up here. So when bromine leaves in solvolysis, right, we form the carbocation you'd expect. Remember, here we're forming a tertiary carbocation, and the higher your carbon degree, the more stable your carbocation is, based on what we talked about with hyperconjugation in a couple units ago. Okay, so remember, this is the point where water, your not great base, not great nucleophile, would come in and attack. Well, while substitution does occur, so does elimination. And the elimination you'd expect is just like the elimination we did in E2. You're actually going to take whatever nucleophile base you're working with, you're going to grab a hydrogen from next door, and you swing the electrons down here to make a double bond, right? And we don't have to have a leaving group because the leaving group already left. So your final product would look like this, right? And I'll draw it up here. Okay, that's E1. It's literally E2, except you have your leaving group leave first through solvolysis. But here's kind of the problem. It's not really a major player as far as, you see the battle between SN2 and E2 kind of button heads, because here's why. If you're thinking to yourself, well, Joe, let's just get a stronger base. If you get a stronger base, let's just say we threw in, with our polar protic solvent, we threw in LDA, or NH2 minus, doesn't matter if it's big or small base, these guys are so reactive, they'll just do E2. They would react faster with this reactant and do elimination by molecular E2 before this bromine would have a chance to leave through solvolysis. So you can't really use a strong base. You kind of have to use a weak base that's going to let solvolysis happen first. However, those weak bases are also weak nucleophiles. So you're always going to have this SN1 E1 mixture product, but I'm going to tell you that this one is always going to be minor. Okay? So basically, you're always going to have E1 with SN1, but E1 is going to be the minor product, and in my experience, someone's going to basically ask you, okay, is there a major and minor product when you're given this reaction? And if you say, oh, that looks perfect for an SN1, then you'd say, okay, we're going to have a minor E1 product, and then you just form the most substituted double bond. Okay? So that's really E1 in a nutshell. I don't even have complete the reaction problems for this on your worksheet that I gave you guys, but I do have a mechanism just so you can draw the mechanism. So at this point, we've talked about SN2, E2, SN1, and we've covered how you get E1 minor products. You guys can tackle that second worksheet, which tells you which reaction that you're going to do. And the last worksheet for this series of videos, I have a whole slew of complete the reaction problems for you, But I don't tell you which one it is. You need to kind of use what we've learned to say, you know what, okay, we've methyl substrate, polar aprotic solvent, good nucleophile, must be SN2, or something along those lines. Use what you've learned, pick apart every aspect of what you're given, substrate, solvent, nucleophile, leaving group, and then you can find out which one it is. Alright guys, once you've done those worksheets and you're ready to move on, let's tackle alcohols.